Hi everyone, it's Peps here. Welcome back to my channel. Today we are going to focus on procedural modeling, and the aim for this video is to create a custom HDA that will take pretty much any kind of curve as an input, and it will generate a procedural brick wall. We will also create a bunch of custom parameters to control the shape of our bricks, and also a custom remesh so we can add some noise, end up with a high resolution mesh, and even the possibility to have some kind of mesh for the grout part that you can use for RBD simulation. So starting from an Houdini empty scene, let's drop down a geometry, call this wall, and dive inside. In here we want this HDA to work with various kind of curves, so let's drop down first a line. We want to make it on the x-axis, 10 unit long, and center it on the origin, so -5. Then let's drop down a curve, and templating the line, we want this curve to be NURBS. Let's go in top view, and by selecting the tool, let's draw something like this. So we have our curved line, and we also want this HDA to work with closed curve. So let's drop down also a circle and orient it on the ZX plane. Let's give it 50 division with a uniform scale of 4 and make it a open arc. Let's plug a switch so we can switch between our test geometries, and drop down a null. Let's call it in curve. So basically this, at the end of the video, we will delete all of this and this will become the input of our HDA. But now, as we work on our HDA, we will be able to switch between these different geometries and make sure that everything is working. And also drop down another null, let's call it control. Here we will place all of the HDA control before we will convert it to an HDA. Let's make it some color like this. And I want this to be pinned all the time. So let's split this pane left, right, make some more room, and pin this one. So no matter what we are seeing, on this panel we'll always have our control exposed. So as we work, we will add the parameters here, and we have always this window pinned. So the first thing, we want to resample our input curve. So let's drop down a resample, and here we want to enable the maximum segment. This will determine the amount of bricks we have. So already here we want to start to create a custom parameter. So let's edit parameter interface here on the control. Let's hide these two guys, make it invisible, and let's drag an integer parameter. So this will be called bricks columns, and here on the name, let's call it b calls. For the range, we want at least, let's say, 1 brick, and for this one, let's put something like 60, but do not lock the range. Now we want to copy this parameter and paste the relative reference here. So let's enable the point display, and we already have our first control enabled. Now this single line will represent just one row of our wall. Basically, let's take a copy and transfer, just to make it clear what the idea is, and a skin node. So the idea is, for each line, for each row of our wall, we will copy the line and skin it, so we will create the surface of one row. And we want to do this inside a for each loop, so we can say how many times we want to do it, and then we can transform and move up each row by an X amount. So first we want to create the control for that. So edit parameter interface on the control null, and we want to be able to decide how much height is a single row and how many rows we want on our wall. So let's create an integer parameter for the row number and a float parameter for the row height. So we'll call the float row height, and row, let's simplify with h, and this will be bricks rows. So b rows. So the height, we want to copy and paste it on the Y translate of the copy and transform. So here. And now we want to create a for each number. Let's plug the resample and move this to node inside the loop. Let's rearrange all of this. And here the iteration number is basically the number of rows. So copy the parameter and paste it here. So now if we go at the end of the loop and put it something like 10, you can see that we have 10 copies, 10 row, but now they are overlap with each other. To fix this, let's plug a transform node after the skin. And here on the y-axis, basically we want to move of the row height. So let's copy again this parameter and paste it here. And this value needs to be multiplied for the number of iteration we are working on. So we want to take this information from here, is the iteration value. And let's rename this to data, so it will be simpler to refer with an expression. And here we want to use the detail expression to take the iteration value from the data node. So detail, and we need quote and the correct path, which is this one. We want to take the iteration value and the index is 0. So now we're starting to have some kind of wall, right? We have the row height, we have the brick row, and here there's something not working. Oh, we need to multiply this. So now we have our basic wall generation. And if we go on the switch and change the index to test also the other geometry, we can see that it's working correctly. Of course, here we will need more brick to have a nicer wall, but it's working. Now we want to start to add some variance to the brick, because maybe we don't want each brick to have the same size. And we will do it with the classic point wrangle. So let's take a point wrangle and we want to plug it after the copies, but before the skin. And here, let me just zoom it a little bit so you can see what I'm typing. So the idea here is, let me enable the point number and maybe decrease the amount. Basically, for each point, we are going to look for the position of the previous point on the curve and move it toward that point by a random amount. So to take the position of the previous point, let's create a vector variable we will call prevPos, and we want to use the point function. From the geometry 0, we want to take the position from the previous point, so at ptnum -1, and close it. Then, since we want this movement to be different for each row, we also need the iteration number like we did for the transform. So let's create an int variable we will call ite, and we want to take it with the detail function. But instead of specifying the complete path, we can plug this to the second input and say 1 here. So instead of the first index, we are taking from the second, which is the 1, because as always we start from 0. We want to take the iteration value and the index is just 0. Let's also create a float parameter for the maximum movement we want. So let's call it max rand. And let's create a float channel chf max rand. Click here, so we have this pair parameter. And the way we are going to move the point is by updating their position, so at p, and we will use the lerp function. Lerp, and we will lerp from the current position and the previous position, so prevPos, and we also need the bias. But just to see how it works, let's just type max run for now, so you can see that something is happening, the pointer moving, and we do have some issue with the first point, but we don't want to move the first and the last point of each row. So let's fix it right away. We want to create a group expression node right after the start of the loop. Let's call it move. It will be a point group. And here we want to exclude the first point and the last one. So at ptnum is different from 0, and at ptnum is different from numpt minus 1. And we want this code to run only on the move group. So now if we move the max rand, you can see that all points are moving except the first and the last one. Now let's create the proper bias for this movement. So let's create a float variable, let's call it rBias. We want this to be random, right? So we will use the run function. But if we use the ptnum as a seed, and let's update our variable, we need to use rBias. We do have something like this. If we watch on the screen, this is happening. And this kind of, let's call it slant. I don't know if it's the correct word for it, but anyway. I mean, it's a nice thing, but we don't want to use this kind of movement right away. For now, we just want to have straight lines. So the bricks will have different sides, but they will not be slanted by default. So what we want to do is to use the position X for the seed. And we do have something like this. Now, if we go at the end of the loop, they are all of the same variation. That's why we created the iteration variable. So let's add also that to the random. So px plus iter. So now they are different for each row. And now we want to use this max rand as a maximum value to control this. So we want to fit 0, 1, all of this between 0 and the max rand. So now we can control it this way. And now we also want to add another seed parameter here, so we can change this output if we don't like it. So after the position, let's make another addition with chi, and we will call this seed, and then we add the iteration. So let's click here and edit this parameter interface. The seed, we want some pretty height range, so we can do this. Now we can control the maximum of variance and also the seed of it. And I actually didn't notice during the creation of my scene, but right now I'm seeing that with this kind of setup, the last line, the last column of bricks tends to be like this. So maybe what we can do, instead of fitting between 0 and the max rand, we can fit it between the max rand multiplied by -1 and the max rand. So now we need to be more careful with this, but we do have a more correct result. So now we want to be able to add that slant effect that we saw before. So let's create an integer variable. We will call this length, and it will be equal to a integer channel called slant. Click here, and this will be basically the switch for our slant effect. So edit parameter interface, we want this to be only 0 or 1. So lock both of those, and we do have this. So now we want to create a condition saying that if this length is on, so 1, then we want to do something. And this something is to add to this bias another value that will be driven with the rand over the ptnum, like we saw before. So rBias, it will be plus or equal the rand function over the ptnum. And here we also want to add another seed. So let's add a float channel, chf, let's call it slant seed. And also the iteration like before. And we want to multiply all of this for another channel that will drive the maximum amplitude of this effect. So max slant, or even better, amp slant. So now if we click here, everything is like before because this is set to 0. This is set to 0, sorry. If we set this to 1 and increase the amp, we are starting to introduce some slanting to our bricks. And we also have the seed over here. Now, just as before, I'm noticing the same issue, so maybe let's fit also this one. And we can fit it between -1 and 1 because we are multiplying by another channel. So now we do have a more correct result. Just like before, be careful with the values, don't do too much. Now we want to create the control for it. And honestly, you could create all of this directly on the control, or even create the HDA first, and so you have all the interface to build the control directly into the HDA, but I prefer to do it this way. I'm terrible at coding, and this is easier for me when I need to debug things, and I need to debug a lot. So we want to edit parameter interface here. And let's see what we need. First of all, let's create a folder. We will call this general, and we will move this control over here. Apply, and we do have the folder. So now we can create another one, and we can call this shape. So we can keep things more organized. And here we want to create this control. So what we have is a float channel for the max rand. So max run on the label and max run on the name. Then an integer for the seed, which is seed, and make the range from 0 to 1000. And here from, let's say, 0 to 1. For this length, here we want to use a toggle. It's more convenient, but we use the integer here because it's easier to use it for a condition. So we will call this slant and on the name also. And we also need another float for the slant amplitude. So slant amp. And a float. Oh, I created a float for this seed, but it will work anyway. So another float. This will be slant seed. And slant seed on the name. Also put a separator here, so we do have this more organized, but this must go here and this here, sorry. Yeah, and we want these two to be hidden when the slant is off, so we take the name of this parameter, and over here on the hide when parameter, we need curly brackets, and slant is equal to 0. Let's copy it and paste it also on this. So now if we apply, they show only when the slant is enabled. So now of course we need to link these parameters. So copy max rand on the max rand and also the other one, the seed with the seed. The toggle will go over here and we have the amplitude and the seed. So now, yeah, it seems to work correctly. Of course, we will tweak the value later if needed, but for now, disable this length and just set something like this. Now, since this workflow will be pretty long, I want to keep things organized and divided by steps. So let's take a null. And this will be our out wall grid. This is the first step of the wall construction. Let's mark it as green. And before the null, let's do a little bit of cleaning. Take an attribute delete and a group delete. So here, let's see what we can delete. Oh, we don't have attributes, so we don't need the attribute delete, but we want to delete the move group. So let's delete every group here. So now let's put an object merge. Let's mark it green, and we want to take this for the object. So from now we can start the second step of our wall. And of course, we can go on the switch and look for the other geometry. Now, even if it seems wrong, this is actually what we're looking for. We don't want any curved brick. If we see something like this, it's just that for this kind of mesh, we need more brick, so we can increase the column. But this is exactly the kind of result that we want from our wall. Let's put back here for now, and let's see. On the second step, we want to create the thickness of the bricks and also the space for the grout. And we want to do it with a poly extrude. So take a poly extrude, plug the object merge, and this we want to use individual element. So we can do something like this without outputting the side. Basically, we will create the face of our bricks. And we also want the possibility to randomize this value. And if you go on local control, you can see that we have local attribute to drive the scale of the inset. So let's enable this, and we will call this grout scale. You can, of course, use the default name or another one if you want. And we want to set this to 1, because this needs to be full value, so we can have a multiplier that correct drive the values. So we want to take another point wrangle, and here we want to calculate this value. So let's call it calc z-scale, because we will use also for the z-scale and the grout. And in here, let's create a comment so we can track things. And here we want 3 value, basically a seed, a minimum, and a maximum value for the grout. So float grout min, chf grout min. Copy this line, let's paste it 2 times. This will be grout max, and change the name. And for the seed, let's make an integer one. I prefer this way, grout seed, and also change the type of channel, so CHI. So click, and we do have this pair parameter here. So now we want to create a float attribute that will pass to the poly extrude. We will call this grout scale, like the name we define here, and it will be equal to grout scale. And for the grout scale, we want to establish a condition, because maybe we just want an uniform spacing for the grout. So by default, the grout scale, it can be equal only to the grout max. So float grout scale. So now display the extrude, and it's not working. Why is not working? Because this needs to be run on primitives. The poly extrude won't take point attributes on for the local. So now we do have the correct things. And of course, this value is limited when you reach the maximum inset value for the smallest polygon you have. And this is a good thing, otherwise we will end up with flip bricks. So if you maybe want more, you need to decrease the maximum randomness. So now you can lower this value even more. Let me put something like this. And now we want to establish the condition. So similarly as we did before, we want to say that if another channel that we'll call rand grout, it will be equal to 1, then our grout scale, it will not be equal just to the grout max, but to a random value based on the point number, on the primitive number, sorry, plus the grout seed, and close the if. So let's set this one to be only 0 or 1 like before, lock the values. And now if we set it to 1, we have this, and we need to feed this value, of course, because we created the channel for that purpose. So feed 0, 1, and all of this will be fitted from the grout min to the grout max. So when this is 0, we have the grout max to control the inset, and when this is 1, we can control the max and the minimum. So let's rename this to grout because we are compulsive. And before doing the extrusion, now is basically the last node where we have just one face representing each brick. So what I want to do now is to create a float attribute that we will carry over and we will use to randomize the color value. So let's take a primitive wrangle. Let's call it calc call. And in here, let's create a float variable. Let's call it call seed. And it will be equal to the prim num multiplied by 1.0 because we need to convert it to a float value, divided by the num prim also by 1.0 minus 1. So now an attribute call seed to bind the variable, and if we create the visualizer right away, you can see that it is randomized, but since we are using the primitive number and we are generating on curves, is basically from top to bottom. So before this wrangle, just take a sort node so we can randomize the primitive sort order, and we have the correct value. So now we want to create the thickness of the brick, and since the curve is basically the spine of our wall, we want to do 2 extrusion, one for each direction. So let's take a poly extrude for the first one, and let's call this thick A. And in here, instead of setting on 1, like for the grout, we want to set it to 0.5. And on the local control, this time we want to enable the distance scale. Also, we want to output the back and the back group. So we can take another poly extrude. This will be thick B. Also this to 0.5, but we want to extrude only the extrude back. And this time, and what is happening? I don't know what just happened with Python. And this time we don't want the back, so don't enable it. But of course enable the z-scale so it will take the same value. So now we want to go back where we calculated the grout and copy everything. And we will use the same workflow to calculate the z-scale. So basically we just need to rename everything. I mean, literally everything. So now we have a bunch of new space parameter and we can control the thickness. And if we enable the random z-scale, that we should set between 0 and 1, like for the grout. Now we have the random thickness over the bricks. So before moving on, let's take a group node. We want to delete this middle edge to clean the mesh a little bit. So basically disable the base group. We want to include by edge, and by the minimum and the maximum we can do this. So now we can take a dissolve node. Let's call this del for delete and dissolve this one. I mean the non-selected one, sorry. So now we have the clean mesh for our bricks. So maybe just put from 50 to 150. Let's also take a normal node because now we are going to calculate the bevel. And also for the bevel, we want the possibility to be different value between bricks and also between points. But actually before, let's update our controls. So edit parameter interface, close this one. We will create another folder, actually another two folder, one for the grout and one for the Z-scale. And let's see, where is the wrangle? So we need for the grout to float and an integer. So 1, 2, and 3. So grout min, grout max, and grout seed for the integer. Also, as usual, give it a little bit of a higher range. Apply, and let's copy paste and move it to the Z scale, and of course rename it. So now we do have our controls, and we also need two toggles. Let's call it random grout, r grout, and the same for the Z scale. Random, where is it? Z scale. Apply and accept, and now we need to link it. So minimum with the minimum and so on. So now we do have our controls. The seed is working, and let's check also the grout. Yeah, we need to maybe remap these values to be more user friendly with the slider. So let's say 0 to 1 is more than enough for the grout. Yeah. And of course here we can also say in the parameter interface that when the random grout is off, the minimum, which we are not using, I believe we are using the minimum or the maximum. The maximum, yeah. It will be hidden. So curly brackets random grout equal to 0. Copy this line and do the same for the Z-scale min, but of course change name R Z-scale. Yeah, it's working. So rearrange things. Now let's build the brick. So first we need to create a group. We can actually copy this one and call this time bev. So with a polybevel node, let's plug it from the group. We want to be applied to bevel, and we can put our distance. But as we said, we want to randomize this value, or at least have the possibility to randomize this value. So just like for the extrusion, we want to set the value to 1 and activate the scaling by attribute. By default, it's driven by the p-scale, but we will create an attribute called bevel. So write bevel here. And here I want to disable these two voices. I noticed during my test it was better with these two disabled, because sometimes the bevel got blocked with the random values. So let's create a point wrangle. This time we are working on points, and let's plug it before the group. Let's call it calc bevel. So here, pretty much identical to the grout and the Z-scale, we want two variables, one for the minimum and one for the maximum. So min bevel, float channel min bev, copy this line, paste it for the max. And now, just like before, float bevel will be equal only to the max when we have this switch turned off. And this is bevel. Now let's create the attribute, which is equal to the variable. Let's create this pair parameter, and we do have the link. But now we want to state that if our switch that we will call run bevel will be on, so 1, we want our bevel to be equal to something else, and that something else is a random value on the ptnum plus a seed, let's call bev seed, close it, and we want to be fitted from 0, 1 to the min bevel and the max bevel. So min bevel, max bevel. Create this pair parameter, and now whenever this switch, which will go from 0 to 1, so if that's on, we do have a random bevel. So now edit parameter interface of our control, and we want to add the folder for the bevel controls, which are basically the same as this, so let's just copy paste and rename the value. Also for the minimum and the maximum, let's just set it from 0 to 1, 10 is way too much for this slider. And let's enable this to visualize also the minimum and copy paste the values. So minimum, maximum, seed, which is always down here, and the toggle for the random. So minimum and maximum, seed is working, and we have the random. But now let's say we want to make more of an abstract wall or a super low poly, so maybe we don't want the bevel at all. And for that we can create a switch to entirely bypass the bevel. And on the interface of our bevel, let's create another toggle, and we will simply call this bevel. Let's put it right at the top, copy the parameter and paste it on the index of the switch. So now if this is off, we won't have any bevel at all. Plus we want to be able to control the division of the bevel, this one. So edit parameter interface, we want to create another integer channel, let's call it bevel division, bev div, and copy parameter here to here. So we're basically done with the second step. Let's copy all of this, and this time I believe we have to delete some attribute. Let's see. We want to delete the bevel, and from the primitive the grout scale and the z scale. And this will take care of the group. So we have position, call seed, and normal. And this will be our out wall bricks. So let's see with the other test geometry, and everything seems to work correctly. Let's increase for this one. Yeah. Now, before moving on into the final step of our HDA, which will be all about remeshing, we actually want to create the mesh for the grout itself. So let me just tweak these values a little bit. Where is the bevel? Let's say we have something like this. For the grout, we want to start from this wall grid. So let's copy a green object merge, and oh, it's already the right input. So we will have the wall brick and the grout. Now for the grout mesh, first we want to clip a little bit on the height. Otherwise we will have this mesh outflowing the final brick. So plug the clip here, and here we want to cut the primitive below the plane, and we need to cut basically the row height. So go back to the general tab, copy parameter here, and paste it here on the origin. So paste relative reference multiplied by the number of rows. So multiply, copy the brick row parameter and paste it after here. So now we have basically the total height of our brick wall, and we need to subtract the grout amount, and we want to take the minimum value. So copy parameter here and subtract it at the end. So we need to add a little more, and we just want to multiply the grout mean by 2. So we end up with something like this. And now for the thickness, we can copy the 2 extrusion we did up here, and let's drag it over here. Display the first one. And for the thickness, this time we want to use the scale minimum, the Z scale minimum, so copy parameter. We want to paste it here and divide it by 2 because we are doing 2 extrusions, so copy the same value on the second one. And they should match. Oh, this is the Z scale max. And I believe we did a little mistake. Yeah, here we want to use the Z-scale min when we are not randomizing the value. So replace Z-scale min here, and let's see, on the parameter interface of the controller, we need to hide the maximum. And for the grout min, instead, it was good the first way. So now if we don't have, yeah, now they match. Of course, this is a problem, but now we can fix the problem. And the way we are going to do it, we want to multiply the value, this value, the distance, for some channel that will act as a multiplier. So on the parameter interface here, we will create a new parameter here on the grout. So let's maybe copy the grout max, and this will be the grout depth. So change the name, and we want this to go from, let's say, 0.5, which is the minimum depth, to 0.9, so we are not ending up with overlapping. Apply and accept, and now we want to copy this value, and before the division, multiply and paste relative reference. So now we can control also the depth, and we want the same value for the second extrusion. All right. So let's check with the other geometry. With the curve is fine. And of course also with this, but as usual, yeah. Maybe the only issue I couldn't solve is this little exceeding of the grout from the end and the start of the curve. But if we, beside can clipping, because in this case there is no clipping direction, which will be fine, I believe it's not an issue because it's pretty rare that you will need a wall without anything at the border. So. And basically this concludes the second step. And if all you need is a low poly mesh, you can basically skip to the point, I will put some marker where when we will create the HDA, because from now on everything we're going to do is to create some custom remesh to add details to the brick and the grout. And also we will use some VDB to obtain a grout mesh with the holes, so it's something that you can use for RBD simulation. Now, for the remesh part, we want to have 3 options. The first one will bypass the remesh entirely, and this will be useful also because until this point, we can edit the wall real time basically, but after the remesh, the calculation will take a few seconds, so it will be a good idea to have a switch to deactivate the remesh, edit our curve in real time, and then activate the remesh again. So what we want to do is take a switch, we will plug it after the wall bricks, and here we will have the other option. So edit parameter interface on the control, and let's collapse these folders, create another one. This will handle all the remesh controls. And on the previous tab, the bevel one, we want to check end tab group. So this will end the tab group and the next folder will be put over here. So we want three options and we want to use a button strip. It works similarly to the ordered menu if you ever use one. So basically we have the menu tab where we can write the different buttons. So we want the first one to be off with no remesh. The second one will be our custom remesh and it will be quad based, so let's call it quad. And the second one, it will be a safer alternative that will use the classic remesh, and we will use the one from the lab node, so let's call it lab. And if you apply, you see that we can have multiple choices because by default you have this toggle field plus multiple selection menu. We want to use the first option, apply, and now only one can be active at a time. And also rename the parameter. We will call this remesh type, and also the name, apply and accept. So let's start to create our custom remesh, and we want to go back here. Let's duplicate this object merge, and we want to start from the wall bricks, so this one. Put the display flag here and let's start. Now we want to iterate on each brick. So here either we use a connectivity node before the for each that we are going to use for the remesh, or we can use a primitive wrangle here after the grout when we still have the situation with a single primitive for each brick. And here we just want to create an integer attribute, we will call it name, and it will sample the primitive number. So this attribute will be carried over until the end because we are not deleting it. And now we can take a for each name primitive. And at the end of the loop, the name attribute is already set by default. So now if we enter the loop, we are iterating on a single brick. Now the idea is to end up with something like this, basically a set of cutting planes for each brick. And to do it, we need basically two lines for each brick, one going on the x-axis, one going on the y-axis. And on those lines, we are going to scatter a set of grid, and we are going to use this grid as a set of cutting plane with a couple of boolean. Now, the trick is to create the lines at the center of each brick. So let me just delete all of this. This was just for example. So the first thing we want to do is to create a single point at the center of each brick. So we can use that point to copy the lines. So we want to drop down a detail wrangle. We want to iterate on the detail just one time, not on the point nor on the primitive. Let's call it this wrangle create center pt. And in here first we need to take the center position, the origin of each brick. And to do it, we just want to create a vector variable. We will call this origin. And we can use the get bbox center function. This one, as you can see, it returns the center of the bounding box for the geometry. And we just need to say which geometry, and of course it's 0. So now let's make some room and create an integer variable that will hold our point. Let's call it pt, and we want to use the add point function on the 0 geometry to the origin position we just created. So now if we go at the end of the loop, disable the single pass, you can see that there is a point at the center of each brick. So now we want to take a split unconnected point, which is basically a regular split set to split only the unconnected points, and also a null. We will call this center pt, and I always forget if it's on the left. Yes. So this is the center point, and on the other side we have the brick without the point. So what we want to do is to take a line and a copy to points node. And on the copy to points, let's just plug the line on the center point. So now we do have something like this. Now on the line, let's copy the length parameter, paste it on the y-axis and put a minus and not divided by 2, so it will be placed on the origin. This is the line going into the y-axis, so let's just copy this copy to points, let's put it on the other side, and this other one will be the one that will go on the x-axis. So let's cut this expression and delete it and set it to 0. We want to set this on the x origin. So now if we merge everything together and also the brick, we do have our line at the center of each brick. Now we need to calculate the length of this line because they need to match the size of our bricks. So we want to go back in the triangle where we created the center point, and in here we want to create those length value. So the first one will be called length. We will use this for the x direction line. Let's just set it to 1. And the other one we will call this height, also to 1. I mean, they will both use for the length of the line, but one for the y-axis, so we need to tell those two apart. And the way we are going to pass this information to the line is by setting as a point attribute. So down here, set point attribute, geometry 0, the attribute will be called len. On the PT we generated the center point, the value is the len variable we created, and we need to set it. Copy this line and let's do the same for the height. So it's height and height. So now on the geometry spreadsheet we have the two variables, and on the lines, this is the one going into the y-axis. Here on the length parameter we want to use the point function. So point, and we need to point it to the center PT null we created. Close the quote. The point will be the point number 0 because there's only one point for each brick. We want to take the height value from the index 0. And as you can see now is 1. If we change this to 2, it's working. So let's take this expression and do the same on the other line, but this time we want to take the len attribute. Let's see, 2 and 2, yeah, they are working. Now we need to actually calculate this len and height value. Now for the height, it's a little bit easier because it's basically the row height. So let's just copy parameter and paste relative reference. This will erase all of your code. Just select this line, Ctrl Z and paste it here. As you can see, it's a little bit longer because we need to subtract the grout, the insetting we did on the single brick. So we want to take this grout max value and we can just copy this line and subtract, paste it and replace the name with grout max, which is the name of this parameter. We need to multiply it by 2 because the insetting is on both sides. And we also want to subtract the bevel. So we also want to subtract this bev max. So copy all of this, paste it right after and change the name to bev max. Basically we are creating some safe margin to make sure that our cutting plane doesn't end up in the bevel part, which may cause some issue with the resulting polygons. For the length line, we actually need to calculate the length of each brick because we have variation, and we want to do it here where we calculated the name. Now we are on a primitive wrangle, so we are iterating on each primitive, and the way we generated this primitive, if we enable the point number, basically the first 2 points of each primitive will always represent the bottom edge, and we can use this to calculate the length we need. So first we need to create an array for each primitive, an array which stores all the points for that primitive. So let's create an integer array. We will call this PTS, and it will be equal to the prim point function with the final s, which returns the list of points on a primitive. And we want to sample from the geometry 0 the current primitive number. So if we want, we can visualize this array like this. And on the geometry spreadsheet, we do have a list of 4 points for each primitive. So now to get the position of these 2 points, let's create a first vector variable, ppos1. We are going to use the point function, geometry 0. We want to take the position, and the point number is the first point on the array, so pts index 0. Let's copy and paste and take the position of the second point, so pts1. Now we want to calculate the distance from these 2 points, so let's create a float variable. We will call this len, and we use the distance function from the ppos1 to the ppos2. Let's visualize it with an attribute, and let's try to create the visualizer for it, which needs to be a marker. And as you can see, we have the length of each brick. So now if we go back on the brick remeshing, this is already taking the len, it is passing. Let's reset the cache. And here we need to take the len variable from the primitive attribute we created. So we use the prim function, geometry 0. We want to take the len attribute from the index 0. Let's move to the front view, and just as before, we want to subtract the bevel value. So let's, where is it? Let's copy this bit and paste it over here. So now we have our lines, and we need to scatter the grid on these lines. So let's take a grid SOP, rows and columns 2 by 2, and we want to copy 2 points, this grid on the lines. So we do have something like this, and we want to be able to control the amount of grid. We don't want to do it with the point line, because the line will have different length, at least in the x-axis, and we want to do it with a resample node after the line. So similarly, like you do in a remesh node, you can specify a maximum length for the cutting planes. And this will go into our control, so edit parameter interface on the remesh tab, and we want to add a float parameter here. We will call this target len, and apply and accept, copy parameter, and paste relative reference on the resample. So now we can control the amount of plane we are scattering. Basically, if we lower this value, we are increasing the amount of cutting. So let's go back in the interface and maybe put some other range. Let's say from 0.001 to 1. So we do have something like this. Maybe we can even lower it, but this slightly depends on the overall scale of your scene. So this is basically up to you. So now we want to finally cut the brick. So take a boolean and let's make some room here. This is where the bricks are, and we want to cut from the brick to the line. And on the boolean, we need to say that set B is a surface, is not a solid. So we do have our geometry being cut. And just for safe measure, let's make this grid very big, so we are sure that it's cutting the brick no matter what. and we want to do a second time for the other set of grid. So copy these 3 nodes. This will go to the other lines. So this is the horizontal line, and we also need to change the orientation here. Let's see, YZ plane. So now we do have this kind of cutting, and copying this boolean. The result of the previous one will be our A set, and the second copy will go in the other set. So we do have our cutting. Let's take a null so we don't see the boolean handles, and as you can see we do have a quad remeshing. I didn't feel the necessity to cut it also on the third axis, but if you want to do it, you basically need to apply the same logic we did to calculate the length for the depth, and you can use the z-scale for that. But I will skip this part because I don't think it's needed that detail on the depth. It may be needed if you need to do some fracturing, but the detail will be handled by the fracture itself. So if you want to do it, by all means do it, but this video is getting already too long. So let's clean this mess a little bit. This is going on the boolean. We can delete the merge, and let's rearrange things a little bit here. So now the core of the remeshing is working, but we have 2 issues to resolve. The first is that if we have, let's say, no grout and no bevel, the curve will be basically matching the sides of our brick. This will generate a cutting plane on the end and on the start of the geometry and may cause issue with the boolean. So what we want to do is, after the resample, let's make a little bit of room. We want to drop down a delete node. Let's plug it after the resample, and here we want to delete the first and the last point of the line. So we want to change the operation to delete by expression, and here we want to delete the first point, so at ptnum is equal to 0, or at ptnum for the last point is equal to numpt minus 1. Change the entity to points, and let's see, template the resample. As you can see, we are deleting the first and the last point on the line. We want to do the same thing for the horizontal line, so let's copy and paste the delete. So we solved the first issue. The second one is a major one because right now it's working, but it's working just because our wall is a straight line. If we switch the curve, you can see that the cutting is not generating some proper geometry. And this is happening because, let me just for a second plug this, because the line of course are oriented all on the x-axis. So basically on the center point here, when we are generating the point for the line, we want also to create an orientation for that point. So we want to go back here where we calculated the name and the length to calculate also the direction. And so finally we can rename this calc name length dir. And here we already calculated the position of the first and the second point of the primitive. And basically if we subtract this position from each other, we end up with a vector pointing to the next point, which is just what we need. So let's create a vector variable. Let's call it dir. It will be equal to the p+1 minus the p+2. Let's create an attribute is equal to dir, and if we create a visualizer for it and make it marker vector, we do have the correct orientation. Just maybe normalize it. It's not needed this time, but just to work properly. So now, back where we create the center point for each brick, we want to create another setPoint attribute. And this time we will use the direction vector, and we will use it to set the normal of our points. And of course, we need to take that attribute to a variable first. So vector dir, and it's coming from the primitive. So prim function from the geometry 0, we want to take the direction attribute index 0. So now if we go on the center point and enable the normal, we don't see it. Maybe we need to reset the cache. Oh yeah. Now if we display the end of the loop and template the curve, we can see that basically now that we have the normal, the line are not going in the right direction. So on the second line, the horizontal one, we want to change the direction going into the z-axis, and the origin, let's delete the expression on the x-axis and paste it here on the z. So now we do have the correct orientation. The problem is that the grid are still scattered in the same axis. So we want to go in the copy to points here and change this thing, because by default the copy to points doesn't transfer the normal. So let's delete this bit. Now same thing for the grid, the orientation need to be fixed. So let's go here on the second grid and change to XY plane. So let's check our cutting and let's see. We do have some... Oh, we need to set this to shutter and everything to surface. We don't want to end with the inner weird polygons. And also on the second boolean. So everything to surface and shutter. After the boolean, let's just fuse the points. And we can delete this null, and after the loop, let's copy one of our green null. This will be our output for the remesh, so out wall remesh. And let's copy an attribute delete. Probably we will need to do some cleanup. Let's see what we have. Yeah, we can delete a bunch of things, height, len, and basically everything but the call seed on the primitive. And also plug a normal node, so we do have our normals. And this is basically the output of the remesh. So now we want to go back here when we are deciding if using the remesh or not. Copy this object merge, plug it to the second input of the switch, and this time we want to take the remesh output. So we want to copy parameter on the switch we created and paste it on the index here. So basically when we say we don't want remesh, we will have the low poly one and we can switch to the remesh version. And for the third input, we said we want to use the standard lab remesh. So we want to take the same input as the first one, the low poly one, and just use a lab fast remesh. It's pretty much as the standard remesh, but it's faster. And here we are giving a warning because by default it looks for a connectivity on the 3D space and UV. We don't have UV, so just use 3D space and it will be pretty fast. We want to use the same parameter we used to control the quad remesh, so copy this one and paste it here. So now let's plug it to the third input, and if we display the switch, we have our three options of remeshing. Now the whole point of the remeshing part is to have more geometry to add details, so we need some control to add these details and we want to use a point board for that. Before, let's just take an attribute promote, so we can promote the call seed, which is on the primitive right now. I prefer to have my color attribute on the points. And also let's take a group, so outside of the HDA we will be able to tell apart the bricks from the grout if we need. So we can call this bricks and we will take all the primitives coming from here. So for the noise, let's take a point bob and dive inside. In here, we just want to use a couple of noises to add some noise to the surface. So let's take a turbulent noise, sample our position, and we will add this to the current position. On the noise, let's set it as a 3D noise and add it to the current position and output to the position. We want to promote the frequency, the amplitude, and the roughness. And for the offset, we want instead to be able to differentiate, because right now, as you can see, they are distorting, but the pattern is like global for all bricks. And we can use the cold seed to sample and generate some random offset. So go back inside. We want to bind the cold seed. So now we are taking that cold seed attribute, which is going from 0 to 1, which is too low for an offset. So let's multiply by constant. And let's set the constant something like 1000. Now let's plug the result into a random. And we want to plug the random in the offset. Let's rearrange these things. So now, as you can see, if we set some high value, you can see that it's not a global noise. There's a lot of offset between each bricks. And we want to do this thing another time, because this first noise, we will use this as a low frequency, then we will have a second one as high frequency. So let's take another turbulent noise, sample our position again, set it as 3D, and we want to set both of the noise as original Perlin. For the second one, promote the same parameters, so frequency, amplitude, and roughness. And copy these two nodes. We want to generate another random offset, but with a different multiplier. So let's say some big number. And feed this into the offset. So actually we need to reverse this, because the random will always give 0 to 1 no matter how big is the input. So first the random and then the multiplication, and same for the second one. So now outside we have the two control for the noise. And of course we don't want to set this too big, and we also want a higher frequency for the second one probably. So let's try to set something, let's see, 0.02, and this will have a lower frequency. Something like this, just to create variation. And this is totally up to you. This is just artistic direction. And we want this control, of course, to be on our main controller. So let's edit parameter interface, and let's close these folders. We want to create another one for the noise. So let's call it noise, apply. And it will go beside the Remesh tab. So in here, let's first drop down a label, and this will be for the low frequency. And we need a vector, so float vector 3 for the frequency, and two float, one for the amplitude and another one for the roughness. So this will be frequency, we'll call this frec1, and this will be the amplitude, amp1, and roughness. Apply. So we have the first set. Now let's just copy and paste it and rename this to high frequency. And we don't need to rename this, we can use the to name. So apply and accept. And now let's copy and paste the relative reference. So frequency. Now maybe go back in the parameter interface. Let's just put some other values here in the range. For the frequency, let's put 0.01 to 1, and for the amplitude and roughness from 0 to 1. It will be fine. So 0.01 to, let's say, 10 instead. and 0 to 1 for both of those. So let's set this one to something like this, and this one is the high frequency, so we have something like this. I mean, at this point it's totally up to you, it's just artistic choice, but we do have the possibility to have some noise. So basically we are done with the bricks. Now we just need to take care of the grout mesh when we do have a remesh operation. So we want to use the same switch for the grout part. So basically when there's no remesh, we have this kind of things with all of our interactive control. And when we have the remesh, we want to switch to another mesh for this grout part. And we want to do it with VDB. So let's take a VDB from polygons. We will plug the result of our extrusion. And on this VDB, we want to be able to set the voxel size through our controller. So edit parameter interface. And we want to create some other channels here on the Remesh tab. So let's create a flow channel. We will call this grout resolution. So grout res, and apply, accept, and copy the parameter and paste it on the voxel size. So 0.1, and we can decrease it to have more resolution. Also reopen the parameter and maybe set the range from 0.001 to 1. It should be more than enough. Then we can convert back our VDB to polygon. So take a convert VDB and convert back to polygons. Here again, we want to be able to control the adaptivity of it. So we can end up with some more of a optimized quote geometry. So go back into the parameter interface and duplicate the grout resolution. We will call this grout adaptivity, hope to spell correctly, and grout adapt. Apply and accept, copy parameter and paste it here. But on this one, we want to be able to set it to 0. So let's change the range from 0 to 1. So this will be the second input of the switch. And we do have something like this. We also want the possibility to erode this grout mesh. So we want to take a VDB reshape SDF, plug it before the convert. Here we want to change the operation to erode and create a new parameter so we can control the amount of erosion. So edit parameter interface again. We will duplicate the adaptivity and let's call this grout erosion. Erode. Apply and accept, copy parameter and paste it here. So now we can erode the grout if we want. Also, why not, we can have the possibility to add also a smooth. So let's take a VDB smooth SDF after the reshape. And here we can decide to smooth it. So edit parameter interface. This is an integer. The smooth works by number of iterations. So let's take an integer value and put it on the Remesh tab. So this will be grout smooth. Grout smooth, and this can have 0 iteration. Apply and also put a separator here, so we are separating the bricks operation of the remesh from the grout one. Copy this parameter, paste it here, so we can have a little bit of smoothing also. Finally, let's duplicate this point VOP, which is the calc noise, and we want to apply the same thing to the grout. So let's plug it after the convert VDB, and we do have our noises. Now we need to create also the control of the noise for this grout part. So we want to go back in the parameter interface, and here we want to create another folder. We will call this brick. and move all the parameters inside that folder. So if you apply, we have a subfolder now. Now we want to select everything, copy and paste. Apply, and we need to rearrange because now it's inside the other folder. So let's drag it to the noise one and call it grout. Apply, and now we have two folders, one for the noise of the brick and one for the noise of the grout. And the naming is already fine, they're just updating by one, so we can accept it like this. And inside the VOP we can delete this offset part because we don't have that call seed anymore, and of course we don't want any randomization over this mesh because this is a single mesh. So all we need to do now is to link this new parameter to this one. And as you can see here, we have all the parameter with the 1 and the 2. And by duplicating it, now we have the 3 and the 4. So all we need to do here is to replace the 1 with the 3 and the 2 with the 4. And basically we have our noise for the grout. So together with the bricks, we do have something like this. Now, as a final thing, I want to add the possibility to have a grout mesh, which will act very good for RBD simulation, which is basically this mesh without the brick parts. And this will be optional, so right away go to parameter interface and create a toggle for it. Let's bring it to the Remesh tab and we will call this grout subtraction. Grout sub, apply and accept. And we do have it here. So now we want to branch right before the smooth. So after the reshape, let's plug the switch and copy the parameter, the grout subtraction, to the index of the switch. So when we don't want the subtraction, we have this mesh, otherwise we will branch out. And what we want to do is to duplicate this VDB from polygons, and we will feed the wall bricks not remeshed, this one, to this other VDB from polygons. And now let's take VDB combine. We want to plug the grout VDB and the brick VDB, and we want to set this as a SDF difference. Where is it? Operation, SDF difference. So we have something like this. Now, of course, it doesn't look very good because if you want to have some mesh like this, you need to work with a lower resolution. But if we plug this to the switch, and let's go where we converted back to polygon, enable the grout subtraction, and if we have a higher resolution, let's say 0.02, we do have this kind of mesh. So everything put together, we do have this. And whenever you're using this, maybe it's a good idea to give at least a couple of iterations of smoothing. So let's go back here and let's move the group as the last node of the brick, duplicate it, and we want to create also the grout group. Let's see, maybe we need to clean something. Yeah, attribute delete. So we can delete the name attribute, we don't need it anymore. And we need this group, don't delete this group. And I believe that's it for our mesh. Now we just need to create our HDA. So to create the HDA, we want to select everything in our geometry and right click on a node, action, and collapse to subnet, or press Shift and C. This will create the subnet. Let's rename it as you want. I will call my easy wall. And now we want to right click, create digital asset. This will open the HDA interface for the creation. You have the label here, the tab submenu where you want to put your HDA, and also the internal name and a bunch of other parameters. I will just click on create, and this will open this window. Let's click apply and accept. Now, from the moment you create the HDA, whenever you want to edit the interface, you can't do it from here anymore. I mean, you can do it from here, but those changes will be saved only on this copy of the HDA. If you want to edit the HDA, and now we need to edit the HDA to have the controls exposed here, you want to right click and choose type properties. Here on the parameter we do have pretty much the same interface as before, and we don't want to recreate all the parameters by hand. We want to go from nodes and look for our control null, this one. And here we want to drag it, basically all the null here. Apply, accept, and we do have all of our control exposed. Now we can disable the remesh and do some change to see if everything is working correctly. But it seems so. Maybe something weird if we exceed, of course, with the rand max. But all the controls seems to be responsive. Now go back inside. Of course, we don't want the curve to be already generated inside the HDA, so we want to select all of this and cut it. And this sub-network input 1 needs to be plugged for the input curve. So now we can paste the curve outside, and if we place the curve as an input of the HDA, we have the same result as before. And if you go inside, we didn't need to set up the output because by saving the HDA, it's already been created correctly. And we can do a test to see if the groups are also being read, and they are, but we do have an extrude back group coming from somewhere. Let's see. It's coming from the grout, so let's take a group delete after the switch and delete all the groups here. And we still have some attributes coming from here. So let's maybe let's just move this attribute delete over here, and let's see. We delete direction, len, name, and PTS. So we have the call seed, position, and the group, and that's it. So now we do have a clean geometry. And of course, let's test the color. So let's drop down a color node, ramp from attribute. Our attribute is called call seed, and also that is working. And basically we did a little change after we saved the HDA. So to apply this change, we need to right click and say save node type. This will update your HDA. So final test, if you press tab and look for the HDA, you will find it here, and it should be working. And it is. Maybe the only thing, if you want to set up some default value for the parameters, you just need to right click with the value you want and choose make current value default. And we basically done. Maybe the only thing you may wondering we forgot is a third option when we want to use the lab remesh for the grout. But the thing is, we created this kind of remesh for the brick because if you apply a lot of slant on the brick, the custom remesh we did may give you incorrect results. So this kind of remesh was more of a safe switch for the brick, but it's totally unnecessary on the grout. And when we want to choose the lab remesh, this switch on the grout will go out of bound and it will keep giving us the second input, so it will be fine. And that's pretty much it for this video. It's gotten longer than I expected. I won't split it, I will put some marker to help you with the navigation, but let me know in the comment if you prefer a shorter video split in more parts. And as usual, I hope you enjoyed my content, and I hope to see you in the next one.